Question 29. In the circuit below, the resistances of R1 and R2 are known. By assuming the ammeter has negligible resistance, the circuit can be used to measure the EMF and the internal resistance R of the cell. However, the resistance of the ammeter can be significant. Under such circumstances, the measurements of EMF and R are described by which of the following? In the presence of internal resistance of the cell, the terminal voltage will be electromotive force minus the I small r. By connecting the switch to R1 and R2, we can then obtain two measured values of the effective current of the circuit. By solving these two equations, we can then calculate the values of electromotive force and the internal resistance, small r. However, if the ammeter also has significant internal resistance, say small r prime, then the terminal voltage must minus an additional I small r prime. This will lead to the existence of three unknowns, which are the electromotive force and the internal resistances of the cell and ammeter respectively. In principle, we need three different equations to get all the three values, but in this situation, we can only have two since we are only provided two resistances, R1 and R2. Yet, we are still able to get the value of EMF but not the value of individual internal resistance. Instead, the best we can do under such restriction is to calculate out the effective internal resistance of both R and R prime. In this case, this effective value is just the sum of the two internal resistances. Hence, the measured value will be larger than the true value. In summary, we still can obtain the exact value of EMF, but will obtain a higher R value, and so the answer is D.